Good morning, students. Let us continue with the exercise 3.1 of chapter 3. Here basically we will cover 3 to 4 concepts. The first one is the concept of ones place. I am making a table that is ones place of number, and this will be ones place of ones place of square. Any number with ones place with 1, then the square will also having ones place as 1. You can check, you can see 11 square, that is 121. 21 square, that is 441. If ones place is at the 1 is at the ones place of a number, then 1 will be the ones place of the square also. If 2 is there, then it will be 4 at the ones place of square. Like 12, the square is 144, it is 4, 2, then 4. 22, that is 484, 2, then it will be 4. If 3 is there, then ones place will be 9. We can also see the example like 13, it is 169, 23, that is 529, and many more, 3 for 9. 4 is 6, any number like 14, that is 196. For 24, that is 576, and 5, that is 5. You need not to remember this. Just 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, we are taking 6, 5 square is 25, we are taking 5, and 6 square is 36, we are taking 6, 7 square is 49, that will be 9, and 8 square, that is 64, we will take 4. 9 square is 81, we are taking 1, and 10 or 0 you can take 0. 0 should always be even number of time. Means either it will be 2, it will be 4, or it will be 6. It cannot be 1, 3 or 5, otherwise it will not be a perfect square. You can take an example. If 10 is there, if we make a square, then square number will be having 2 zeros. If it is 100, then it will be 4 zeros. So 0 cannot be odd times. This concept covers 11th, 12th, 13th question. So in 11th, 12th question, we need to give the reason why the given numbers are perfect square. One of the example I am taking, that is 7928. 7928. This is given. This is not a perfect square. What will be the reason? This number ends with 8. So it cannot be a perfect square. So in this way you can give a logic for all the questions. Like in 11th question, the third part is 530. So 530, it includes 0. 530, there is 0, but the logic is 0 cannot be in odd number of times. So 0 is odd number of time, so it cannot be a perfect square. You will give the reason like this. Also in 13th question, part 3, the number is 64,000. 0 are odd number of times. You will write the same reason. 0 are odd number of times, so it cannot be a perfect square. One more example I am taking, 89722. 2 is, this number end with 2, and 2 cannot be a ones place of a perfect square number. You can write in this way: 2, this number ends with 2, and square number, or you can say perfect square. Perfect square cannot end with 2. You can see by the table, every number will be having these as ones place. Any of these will be the ones place of any number. So if these are the ones place, then these can be the ones place of a square number. So the 2 what we get in the given, in the example we took, 2 is not in the list. That's why it cannot be a perfect square. Also, if you want to if you want to cross check it by prime factorization, you can cross check it. All the numbers will not be in, all the prime factors will not be in the pair. Second logic, that is this concept just I told you, that will be applicable for 11th, 12th, 13th question. For 14th question, there is new concept that we need to tell that the square of which of the following would be an odd number. For an odd number, square will be odd. How? If we see 13 is odd number, its square 169, it is odd. If we take 11, its square is 121, it is odd, it is also odd. If we take any 9, it is odd number, so its square is also odd number. For even number, an even number, square will be even. Like 12, the square is 144. 14 square is 196. So for even, the square is also even, square is also even. This will be applicable for 14th question. Perfect. 15th question is also the same. Like 15, show that the following numbers are not perfect square. First one is 5, 9, 2, 7. 7 is at the ones place. That is not possible for a perfect square number. So in this way you can give the answer of the 15th question as well. In 15th question, the third part is 5 times 4. Here 4 is the ones place, so it can be the perfect square number, but it is not necessary that this will be a perfect square number. So for this we will prime factorize. This is 2, 2, 2, 2, 2. Then again 1, 1, 1, 1, 1. This is prime number. Also, if we will try with the prime number, we will get the prime factors are not in pairs. If they would have been in pairs, then we could have say that this is a perfect square number. They are not in pairs because this is the single one, this is prime number, this is the single one, only pair of 2 is complete, so this is not divisible by any other number, so we can say this is also not a perfect square number. So 16th question, we need to check, like 484 is given, we need to say whether this is a square number. Like let me write the statement of 16, which of the following. We need to tell which of the following, that is first one is 484, whether it is square, it is a square of even number or odd number. As it is even, so it will be square of a even number. It is even, so it will be square of even number. It will be square of even number. So even number will be having even square, odd number will be having odd square. So here this number is even, so it is a square number, because in the statement it is given these are the squares. So it is square of 22. You can also check by prime factorization. You can see this is square of 22. 22 is even, this square is also even. In this way you can answer all the question. 1, 2, 2, 5, this is given, this is odd number, so this will be the square of a odd number as well. So if we will find, this will be square of a odd number. Next concept is Pythagorean triplet. This one we have covered in the previous video as well. This time also we are covering. What are the Pythagorean triplet? These three are the Pythagorean triplet. One is necessary to give. Any one will be given to you, and you need to find the other two. Like first one, I'm taking an example, like any one is 14, find the other two. For the even numbers, I specially suggest you equate with this only, like 2m, that is equal to 14. So m will be equal to 14 divided by 2, that is 7. So m has value 7, so by putting m here we will get m square minus 1, that is 7 square minus 1, 49 minus 1, that is 48, and m square plus 1, that will be equal to 7 square plus 1, that will be equal to 49. So the numbers are 14, 48 and 49. Here you can cross check. 49 square will be equal to 48 square plus 14 square. These are the Pythagoras, this is the Pythagoras theorem they are verifying. These are the Pythagorean theorem. Especially for the even numbers I suggest equate with this only, because this is even and we will get a integral value of the m. Integral means only the positive integer value, natural number value of the m will be considered here. No negative, no fraction value will be considered here. In some of the cases you can equate with this and you will get the value of m as integer. So in some of the cases equating with this you can get a value of m as integers. This one these two you will apply only when this number, the given number, is odd number, only then. Otherwise in 18th and 19th question both are given as even numbers. In 15th question it is given the smallest. Out of these two, this is the smallest. This is smallest. The next concept we are going to cover is repeated subtraction. Remember one thing before doing this, I told you like 49, it is a square of 7, so it can be represented as the sum of consecutive odd numbers. How many? It is square of 7, so there will be 7 numbers. 9 plus 11, these have been 6 and 13. You can cross check this also. Their sum will be 49. We are just reversing this process. We have added these, so one by one we will start subtracting them. If it is a perfect square number, so at the end, at this last odd number we are subtracting, we will get 0. So that is the exercise 3.2 we are covering. There is only one type of question in 3.2. There are 8 questions and all will be done in this way. 48 minus 3, that is 45. 45 minus 5, that is 40, and 40 minus 7, that is 33. 33 minus, next one is 9, that is how much? This will be 26, and 26 minus 11, that is 20, that is 15. 15 minus, it is 24 here. 24, this 24 minus 11, that will be 13 here, and 13 minus 13, that will be equal to 0. In this process we will do all the questions. Like one more we are taking an example, 64. 64 is square of 8, so there will be 8 step, means 8 odd numbers you need to subtract. First one I am subtracting 41. 64 minus 1, that is 63, minus 1, that is equal to 63, and 63 minus 3, that will be equal to 60, and 60 minus 5, that is 55. 55 minus 7, that is 48. 48 minus 9, that is 39. 39 minus 11, that is 28. 28 minus 13, that is 15, and 15 minus 15, that is 0. How many steps? 1 2 3 4 5 6 7 8. In 8 step we get 0, so it is square of 8. In case we didn't get 0, so this will not be a perfect square.